So in 7.2, we take a look at radical expressions and how they can be represented as rational exponents or fractional exponents. There's a quick review of exponent rules up here. We're not going to really need a whole lot of them necessarily in this section, but since we're dealing with exponents, I want to remind you of them. There is one, this interpretation of a negative exponent that will be crucial a little later on here in this section. But looking at this important idea, here's really the key point in this section, and that is that an nth root, right, the n is the index of a radical, can be represented as a fractional exponent of 1 over that value. This is important, this is key. The relationship between radicals and exponents is very important, and understanding this notation will be very useful. Right now, first thing we'll do is just kind of get used to interpreting the rational exponents, the fractional exponents. So 32 to the 1/5 power, we will always be able to, if it's useful, if beneficial, interpret the 1/5 power, that 5 as an index of the radical, to call that the 5th root of 32. Asking for something that would be taken to the 5th power to give you 32, turns out that's 2. 2 to the 5th is 32, so the 5th root of 32 is 2. Now, the next one. When we read this goes back to understanding exponents. This 1/2 power is only a power, only an exponent of the 16. The negative is not included. The negative is sitting outside of this 16 to the 1/2 power, so I can interpret this 2 as a square root. You can put the 2 in there if you want to, but again, it's usually implied. So this is the negative of the square root of 16, and that would come out to be a negative 4. Square root of 16 is 4, no issues there. Contrast that with number 3, where we've got the 1/2 power outside of these parentheses, and now we're saying the square root of negative 16, and again, right now, negative radicand with an even index. This is not a real number. Okay, and for now, that's how we'll leave that. Again, we'll eventually get to more on that. And then number 4, same kind of situation, only now it's a 1/3 power, so 3 is our index on our radical, and this is a cubed root of negative 8, odd index we're able to work with, and so this would come out to be a negative 2, because negative 2 is the number you cube to get negative 8. On the next page, we expand this a little bit to point out that a base can be taken to a power that has both a numerator and a denominator, not just a 1 over a number. And in which case, that m has its own interpretation. Notice even the order they're interpreted doesn't matter. The m itself is the power, while the n is the index of the radical. So your numerator is the exponent, your denominator will be the index of the radical you're dealing with. So with that said, we can now take a look at something like 27 to the 2/3. Now I'll point out, with these two notations, notice what we're saying is you could take your base to a power and then take the root of it, or have your base and take the root of it first and then take the power. Well, consider when you're working with numbers, it's much simpler to take a number and make it smaller by taking its root first and then raising it to a power. So this would be the more convenient approach, if possible, if you can take that root of that base to do that first, rather than making the number bigger and then trying to figure out its root. However, there might be times where this approach in using the power first would allow you to then successfully take the root afterwards. So just something to keep in mind, to consider. But in these two examples here, the first thing I want to do is interpret them. 27 to the 2/3 power. So that'll be 27. And again, that's the 2 is the power, the 3 is the exponent. I'm going to go ahead and say, sorry, the 3 is the index. I'm going to take the cubed root of 27 and then square it. Again, I could have put that squared on the inside, but I don't want to square 27 to make it much bigger and then look for the cubed root when I realize the cubed root of 27 is just 3, and now I can just square 3 and get my final answer. Same over here, 100 to the 3/2 power. I'll think of it as 100. Now, if I want to think of it as the cubed root first and then squared, notice that's not going to work, right? The cube root of 100, something cubed to give me 100. Oh, I botched that up. that is supposed to be the square root of 10 cubed. My apologies. Let's try this again. The square root, 2 raised to the third power. The square root of 100 does come out evenly to 10. Then I can take 10 and cube it and get 1,000. I was thinking ahead of a problem later on where we will learn what we can do if this approach doesn't end up working nicely. Okay, last couple examples here. You'll notice on 3 of the 4, we have negative exponents. And in fact, I believe we'll even throw a negative on that one, as that's supposed to be a negative as well. So, with a negative exponent, that's where we want to make sure we recall our properties of exponents. And remember that a negative exponent can be interpreted as essentially that base belonging in the denominator or in the other part of the fraction, right? Either it's over 1 and belongs down here, or it's in the denominator and belongs up top. Either way, you're kind of moving that base to get it where it belongs. And so, with an 8 to the negative 2/3, we would first rewrite that as 1 over 8. And now we can have that be to the positive 2/3. We've moved the base where it belongs. Now we have the positive exponent. And now we can go on interpreting it as the cube root of 8 squared. And so the cube root of 8 is 2. And then that 2 needs to be squared to give me 1/4. So I want to get that written out and then talk through it again. The 2/3 power, we get that cubed root in the second power. Then you've got the cube root of 8 giving you the 2. 2 is what is being squared, giving you the 1/4. It's important to make sure we do rewrite this first. We need a positive exponent before we reinterpret it. Okay, we want to see it in the right form before we interpret that exponent. And so we'll do that with each of these. Now for the next one, notice the 8 is a negative, and I'm not going to be concerned about that. The negative exponent is the issue. So that I would first address by moving it to the denominator, and notice that will change the sign on the exponent, not the sign on the 8 itself. Right? Definitely do not change the sign of a base in order to move it. Now we can rewrite it as the cube root of negative 8 squared. And so now I can cube root of negative 8 and get a negative 2, which I then need to raise to the second power. And so negative 2 times negative 2 gives me a positive 1/4. Looking at the next one, we want to point out that the negative is not going to be included in what's being raised to this power, as we saw earlier. The exponent will only apply to that 8, so the negative sits there while we look at 1 over 8 to the 2/3, which I can then reinterpret as the cube root of 8 being squared. Then take the cube root of 8 and get 2, and then square the 2 to get 4, and end up with a negative 1/4. And so notice the order or what things applied to and how that negative stayed outside does definitely impact what you are actually calculating and that final answer that you get. Okay, and then this last one here, a little bit of the exponent rules from the previous page there. But first, this negative exponent on this fraction, just as a reminder, we said it means it's in the wrong spot, the base. Another nice trick is if you have a fraction to a negative exponent, it actually is as simple as taking the reciprocal of that fraction. And then that will turn that exponent positive. It's a nice trick as opposed to putting it as a 1 over and having to rewrite it a bunch. You can just take the reciprocal. Now, that means we've got 27/8 to the 2/3 power, and officially, we'll see on the next page this works another way in radical form, but in exponent form, that means you can take each of those pieces to that power and then rewrite as cube root squared and cube root squared. So that'll be 3 squared over 2 squared, giving us 9/4. That's one way to approach that problem there.